So today you're going to have a couple of problems just like this, where we finished up yesterday, where you've got, listen up, you have to plot the 6 ordered pairs of the triangles, connect them. Then you have to do the distance formula 6 times, and you have to compare. So on this particular problem, I had, and don't bother to simplify the radicals. Just look at the number of the radical. I had the square root of 17, the square root of 17. So that's one set of congruent sides. Then I had the square root of 5, and the square root of 5, another set of congruent sides. And finally we had the square root of 18, or the square root of 18, a third set of congruent sides. So yes, the triangles are congruent. Therefore, the triangles are congruent by SSS postulate. Yeah, that was that last problem that we finished up with yesterday. So you'll have a couple just like that. Then, let's look at your notes. So if you didn't finish that up, you can finish that up later. Look at your notes, flip it to problem 2. What other information do you need to prove triangle LEB, that's this upper triangle, is congruent to triangle BNL? And as you see from the picture, you've got one set of angles congruent. So just by the picture, because you have to look to see what in the picture have they given me, what else can I prove without any help, then what else would I need? So right now, haven't they given you that angle L is congruent to angle, and I can't say L, can I? Let's try again, because there's 2 angles with L. So angle ELB is congruent to angle LBN. So that's an A. Then what else in the picture can you prove is congruent without any help? Very good. So we can prove that segment LB is congruent to segment LB all by ourselves with no hints. So with an A and an S, what else do I need? Another side. But I specifically need the side that's going to include those angles. So if I've got this angle here, make it in red, I've got that angle there, and I have this side. And I'm just going to look at the top triangle. What other side do I need? There's only one side I can choose from, because there's side EB or side LE. Side LE is the side that's going to include that angle. So I need LE is congruent. What is the corresponding side to LE? NB. So I need another side that creates the included angle. So they're not looking for the LB is congruent to LB, because that you can prove by yourself. They're looking for the LE is congruent to NB. But you needed to identify that you could prove LB was congruent to LB via the reflexive property. But that's not the one that we need help with. Because if that's all that they gave me, I wouldn't be able to prove the triangle's congruent. And so that's what they're going through here with you. So let's move on to problem 3. So they use a lot of words for something very simple. So look at that picture. Are the triangles oriented correctly? No. But know what they have marked on the triangles. Excuse me. You guys are constantly talking while I'm talking. So they have given you all 3 corresponding sides are congruent, and they've given you one set of corresponding angles congruent. So here's the questions. Use blank if you have 3 pairs of sides congruent. 3 pairs of sides congruent, what would we use? SSS. Use blank if you have 2 pairs of sides and the included angle, emphasis on included angle congruent. That's your SAS, right? So here, what, obviously the three sides are going to be your SSS. What sides are going to be your SAS? The single, double, or triple tick mark sides. What sides include that angle that's right here? The single and the double? The single and the double include the angle? Good question. This one has the single and the double here. This one has the triple and the double here. Have they given you the same corresponding angles? No. Interesting, right? So you're right, these two sides would include that angle, and these two sides would include that angle, but they are not the same sides. So therefore, you could not prove those triangles congruent by SAS, because it's not the same two sides. Does that make sense? But you could by what? SSS. For what you know now. Let's put it that way. True or false? The diagram shows congruence of three sides. That is true. In the triangle on the left, the marked angle is the included angle of the side with 2 marks and the side with 3 marks. We just said that was true, right? And then in the triangle on the right, the marked angle is the included angle of the side with 2 marks and the side with 3 marks. That one's false. So therefore, you cannot prove the triangles congruent by SAS in this case. Not with what they've given you and what you know at this point. Yes, no, yes, no? Okay, flip. Oh, we just talked about that, so we just wrote that one. All right, so the last part, your friend thinks that the triangles below are congruent by SAS. Is your friend correct, and explain? So I want you to run through questions 23 through 26, and feel free to use the help of your pair share partners, people around you, in other words. All right, so questions 23 through 26. Come up with answers and discuss. All right, are you ready? Are 2 pairs of corresponding sides congruent? Everybody, yes or no? Yes. Wait, what? I know. Are 2 pairs of corresponding angles congruent? Yes. Are the congruent angles and the included angle between the corresponding sides? Or is that the included angle? And I purposely highlighted the 2 sides. That's the angle that's created, the hinge that's created between those 2 sides, and that is not the angle that is congruent. So this is side angle, a bad word spelled backwards. So the answer to that is no. And so therefore, no, you cannot prove the triangles congruent by SAS because the angle is not included, and you cannot prove triangles congruent by SSA. What would you say? Okay. Make sure that you put that in there for your note purposes, because that's huge. Because that's the one thing that they'll try to get you to do all the time. Because you're like, oh, I got two sides and an angle. It has to be the right angle. Because remember, I can take that hinge right here, and this angle is not stuck at a particular angle measure. So I could squeeze that closed, still having that same angle measured there. But this side across from it becomes smaller. And so it's no longer the same as that. They still have that angle in common and those side lengths in common, but that third side is no longer the same. All right, so let's look at your workbook. Turn to page 95. Let's start down here. Let's look at these ones. Would you use SSS or SAS, this is page 95, to prove the triangle's congruent? If there is not enough information to prove the triangle's congruent by SSS or SAS, write not enough information and explain your answer. In other words, let's go through a couple and I'll let you do the rest on your own. So look at number 4. Here's my sides that are congruent. Bless you. Is that angle included in the sides? No. So, you're going to write not enough information. And then you're going to explain the answer. And my explanation to this one would be SSA. Correct. For our purposes, if you write SSA as an explanation as to why there's not enough information, I know what you're saying. All right, look at this one. We have this side congruent on this triangle and that side congruent on that triangle. And then we have one set of congruent angles. So we only have 2 sets of congruencies. Is there a third set? Like on this one, they gave us all 3. This one, they gave us only 2 sets of congruencies. Is there a third set that we can prove without any help that's congruent? We've got a side and an angle, so we need some sides. What? EF. So right on here, EF is congruent to EF. And so what are you going to prove the triangle is congruent by now that we know this without any help? SAS. Here I've got 2 sets of congruent sides. So I've got side, side, but there's only 2 of them. Is there either an angle that we can prove congruent? Usually that's vertical angles. Or is there a side that we can prove congruent? Can you check? Sorry. Side KO. So we can triple tick mark KO is congruent to KO, and that gives us a third side. So then you do those 6 all by yourself. Don't consult anybody yet. And decide if you have enough information or not. Bless you. All right, now consult with those around you and see what they say. Eric, did you talk to somebody? Talk to another person because you're done. Go to your left. Ivan, did you talk to somebody? Talk to Dominic behind you. On which one? Uh-huh. Correct. You'd have to name each of those angles with 3 letters.
So you could just say like
No. You have to name like one angle PTF. You mean on number 11? Right. Okay, so here we go. Look at these. So I wrote a lot of stuff. So I added to here no, yes, yes, by the way. And then here, this is a no because although they give you 3 pieces, actually don't give you 3 pieces, you can prove that ZY is congruent to ZY on your own, but it doesn't do you any good because that does not make this angle here the included angle. It makes SSA. So therefore, there's not enough information to prove the triangle is congruent. Even though you can get 3 pieces, it's not the right 3 pieces. Here, they've given you all 3 sides, so there's nothing that you need SSS. So that one's pretty straightforward. Yes? Like on which these ones? No. Mostly because they've tick marked them for you. If you had to name the triangle congruent statements, like if you were asked to then, okay, yes, then write the triangle congruent statement, then if I were you, yes, I would redraw one of them for the purposes of getting the angles in the correct order. But for this particular question, the way they asked it, no. This one, they've given you all 3 pieces. They've given you 2 sides and an angle, and that creates the included angle in between those 2 sides. So yes, by SAS. So there's nothing that you need on that one. Then on this one, you can prove that NR is congruent to NR, but that only gives you 2 pieces. So I forgot to write in there, not enough information. So you definitely don't have enough info here to prove by SAS at all. This one, you can prove the vertical angles are congruent without any help, so you have to name them as angle PTF or FTP is congruent to angle STG or GTS. And that will give you SAS. You don't need any information because you can prove that. And then here, you can prove either with SSS or SAS. They've given you all 3 corresponding congruent sides. So that's SSS without any additional help. But you could also prove the vertical angles are congruent, CDT and angle HDR, and so then you could prove the triangle is congruent by SAS as well. So either one is acceptable in that last one. This one's more work because you have to add something in there. So any questions on that? So that kind of brings you into that's your pre-proof planning right there. So you've got to be able to look at the picture and decide, is there something I need? Is there something I can prove by myself? Where do I go from here and how am I going to prove the triangle is congruent? So flip the page over and let's look at the 2 proofs. Because you're going to have several proofs today. That's very exciting. 2 proofs. All right, so you will see me labeling things as S's or A's. And I'll be marking up my picture if it's not marked up. So look at the first proof. You are given that BC is congruent to DC, so those are single tick mark, and that's an S. And then you're given that AC is congruent to CE, or EC, and that's another S. We have to prove the triangle is congruent. So it's either going to be SSS or SAS. What can you prove by looking at the picture all by yourself without any help? I can prove this is congruent to this, right? So angle, and you're going to write that up here in your pre-proof planning. So angle BCA is congruent to angle ECD. And what is that? Side or angle? So angle. Is that the included angle in between the two sides? So we're going to prove the triangle is congruent by SAS postulate. And I'll always put that next to my congruency statement. So that's the progression I'm going to put my proof in, SAS. Now, you don't have to split your given up. In fact, your book probably won't split your given up. I will, because I like to teach you to go on that progression. So, the very first statement, we're going to choose one of our sides. So we're going to choose BC is congruent to DC. Reason given. So off the side, I'm going to put S. And I want that progression of SAS. So I'm going to cross out the S, check off. Then my second step is going to be to prove an angle congruent. Sometimes it might take a couple of steps to get there. In this case, it just takes one step. So I've already pre-planned that I'm going to say that angle BCA is congruent to angle ECD. Why? Vertical angles are so you can't use definition of vertical angles, so I don't care what your book may write in there or whatever. So that's my A. What's next? Oh, I'm going to cross that off. What's next? Yeah, my other S, right? So then step 3 is going to be AC, segment AC is congruent to segment EC. Why? Given. And so that's an S, and I'm going to cross that off. Immediately upon hitting that third piece, what can I do? You've proven the triangle is congruent, so step 4 is your congruency statement, exactly as the proof wrote it. Triangle ABC is congruent to triangle EBC. Why? We wrote it right there, SAS postulate. Isn't that easy? You have an idea of where to go, and you have an idea of exactly what order to go in. These are the easiest proofs you're ever going to do, because you know the progression, the order the proofs go in. The problem is you have to figure out what else you can prove. And so it shouldn't be that difficult right now. You're either going to have sides that they share, or you're going to have vertical angles, or something interesting like that. So then I want you to look at, oops, what did I just do? I have no idea what I just did, but it went away. Oh, I took a picture. Yeah. All right, so on this one, notice in your given, and so we've got to have our statements. And our reasons. So notice what they have given you. They've given you parallel lines. Well, that's not sides or angles, so we'll hold off on that. But they've given you this. Side WX is congruent to side WZ. That's an S, isn't it? Well, we need 2 more pieces. They must have given us parallel lines for a reason. So before we use that, let's think about some stuff. Look at the picture. What else can you prove without any help? Don't the 2 triangles share a side? So one of the things that we're going to have to add in here is that ZX is congruent to ZX, and isn't that an S? So I've got SS, so I have to decide, is it going to be SSS or SAS? What am I going to do with parallel lines? Can we prove lines congruent with parallel lines, or do we prove angles congruent? Ian, really? When your head is on the desk, it's extremely disrespectful to your teacher. It's telling me that what I have to say means nothing, which is probably true in your view. But in college, you're going to get kicked out of class. Don't even bother to go to class. So quit sitting on your desk, or you're going to stand. Sitting, leaning, sleeping, something. All right, so what am I going to prove with the fact that these lines are parallel? Isn't this a transversal? And if I know that this side, where's my highlighter? If I know that this side is congruent, and I can prove that that's one of the congruent sides, where's the included angle? Right here. What angle is this congruent to on parallel lines with a transversal? That one right there, isn't it? They're alternate interior angles, aren't they? Yeah, we could have corresponding, but not in this particular picture. So in this particular picture, we have alternate interior angles. So I can say that angle WXZ is congruent to angle, whoops, can't see that, is congruent to angle XZY because alternate interior angles are congruent on parallel lines. I'm just going to abbreviate it. And doesn't that give me an A? And that's the included angle. So we're going to prove the triangle is congruent by SAS postulate. So that's the progression my proof takes. So I'm going to split up my given again. I'm going to start with side. So my very first statement is going to be a side. Well, that's one of my givens, because you always want to start with a given. So I'm going to start with a WX. Doesn't matter that it comes second. Is congruent to YZ. And the reason why I like you to go in the proper order is, what if you went in the order of SSA? Some of you are going to fall into that trap of saying that the triangles are congruent by SSA. Which, can you do that? No. And so that's why I kind of insist that you try to go in the order. All right, so this is given. And it's my first congruency statement. So there is an S. I'm going to cross out the first S. What's coming next? Yeah, the angle with the parallel line. So in order to prove the angle is congruent, I concluded, I used this right here to make that conclusion. So we do have to start with a parallel line. So step 2, I'm going to write small, WX is parallel to YZ. How do I know that? Given. That does not give me an angle or a congruency statement at all yet. From there we concluded that the angles were congruent. So step 3, angle WXZ is congruent to angle XZY. Y. Yep. Alternate interior angles are congruent on parallel lines. So I really paraphrase that short, which is good. It's okay. So that gives me my A. Then what can I do? Yeah, so now I have my final S. So I've got 4. ZX is congruent to ZX. Wow, they really didn't give us much room. And so that was what? We forgot to write it in there. You can't say a shared side. We don't have anything that says shared sides are congruent. Look at it itself. The same thing equals the same thing. That's that reflexive property, right? So reflexive property of congruent segments. And so that gives me my S, my final S. What immediately follows from there? Yeah, so step 5, which I'm running out of room, so I'll just write down here. Triangle WXY XZ is congruent to triangle YZX. And the reason is SAS postulate. Not so bad. That's a little harder proof. Yes.
Can you also just say for the alternate to your angles that like X is congruent to Z for your alternate to your?
No, because there's two angles associated with X. There's this angle and that angle, so I don't know which one you're referring to. You have to name it with 3 letters. Any other questions on that? Okay.